Hello, in this video I want to show you how you can debug CAN interfaces with an oscilloscope. For this I have an RTO oscilloscope here with already a CAN decoding set up. At the moment I'm in stop mode and you see that the signal is quite decent, and you see that I capture at the moment 4 frames that are all okay, what you see in the decode table here. You see that they are okay as well with the color coding, because there's no red color coding besides the last one. The last one is always red because it's an incomplete frame, as you see here as well. It's insufficient length, so we didn't capture the complete frame. So let's now look into a longer capture so that you see more of that frames and look for any errors. So we can go to, let's say, now we are having 20 milliseconds per diff, so it's 100 milliseconds capture. You see we capture a lot of frames. I just make a single run, and we capture lots of frames. When you go through the list of the frames, you see we have captured now around 100 frames, or more than 100 frames. Now we can debug and look into that frames. To do that, the easiest way is to go through the decode table and look and check for any errors. So you see the first frame is okay, the second has a CRC error. Somewhere later you have a bit stuffing error, you have a CRC error again. So you see there are some errors in that capture, and we have to really look and dive into it. So there are several methods to do that, to analyze that. The simplest way is to take that capture and look into the details of that error. So when we look into the bit stuffing error, for example, we can activate the zoom coupling. When you do that, you jump directly with a zoom to that error frame that we have here in the CRC error or the bit stuffing error. So here you see the error frame that was causing the bit stuffing error. Remember, CAN, you need to have a stuff bit every 5 consecutive highs or lows, or dominant or recessive bits. So at this capture, which is recorded of a, let's say, 50 kilobaud, you would expect every 100 milliseconds or microseconds a stuff bit. So let's work with a cursor and check for the error here. When you move the cursor, just do the horizontal cursor here, you see the cursor values are changing when I'm moving and measure the distance between those two. You see we are at 120 microseconds, so we are having, and this is actually causing the bit stuffing error, because now we have 6 consecutive lows or recessive. So this is causing the problem. So this specific bit. Now the next step would be to further analyze which one was the source address, which is the causing that problem, and maybe replace that one. An alternative approach to analyze the signal and to debug is, of course, to work on it with a trigger. So when you look for the trigger, you can trigger on any specific CAN telegram, and you can trigger on error conditions. So when you look into that, you can trigger on CRC error, bit stuffing error, form error. So let's just trigger on the bit stuffing error. And of course, now it does make sense to remove the zoom coupling, remove the zoom, and go into a more, let's say, single frame situation, and now run the scope. And you see you're stable triggering on the error condition. And when you now dive into that one frame, you see that it's always the same frame with the same bit stuffing error. So that's an alternative approach how you can debug the bus interface, that you either search through the table, manually browse through the table, or work with the trigger conditions. So with this, you're able to really analyze in depth the CAN telegram, the CAN bus communication, and debug any problems that are coming from either logical side or from the PHY or through EMI emissions or bad cabling, bad wiring and all that.